Okay, so now that we've figured out that there are cations and anions, and our cations are mostly metals and they're positive, and our anions are mostly nonmetals and they're negative, now we need to put them together into forming our chemical compounds and making our chemical bonds. So to do that, we have a little step-by-step to go through with our diagrams, and then we're going to go through a couple together just to make sure that you understand it. So I'm just going to keep trying to focus. There we go. What's going on here? So we're going to go back to our lithium and our fluorine that we know so well. So we're going to use lithium and fluorine as our example. And to do that, we're going to write our metal, which is lithium, and our nonmetal, which is fluorine. And we're going to draw their Lewis dot diagrams, which I've already done for you over here. So Lewis dot diagram for, oh, this isn't lithium. What am I talking about? I just want it to be lithium because we've used it in every other one. I'm sorry. This is potassium. Potassium and fluorine. It's the same thing. They're in the same row. That's why I was, just getting used to writing the same one over and over again. So our potassium has one valence electron. So this Lewis dot diagram is going to show us only the valence. And the reason why this is important is because potassium is actually in our fourth row of our periodic table. So underneath here, see, here's our potassium in the fourth row of our periodic table. And that means that we have 4 energy levels. Only the fourth one has our 1 electron in it. So now we've drawn them, and we're going to use an arrow to show where our electron transfers. This is how can we represent an ionic bond. So it's very important, this word transfers, because the transfer of the electrons is what makes the ionic bond. If you don't have a transferring of electrons, you're not going to be forming an ionic bond. So this will lend, the cation will always give to the anion. The cation will give or lend to the anion. Always. It always goes from the ones that are going to become positive, or our metals, give to the nonmetals. So here's our arrow here saying we're going to give this over here to our fluorine, and that is going to be how we're going to get our charged particles. So our 2 ions that are going to be formed are here coming from our positive because we've given away 1 electron, and our negative because we've taken in 1 electron. So it says write, we've already done this, write the 2 ions that have formed. The element symbols and charge go into the top right. That is important where you write it, is that it's on the top right hand side. Okay. So then we're going to do crisscross. Honestly, can't even read that. Crisscross, the charge numbers. Not the positive or the negative signs, to make them into subscripts. So we're going to take this charge here and we're going to move it down over here. We're going to take this charge here and we're going to move it down over here. And that is going to tell us how we are going to create our new compound. So our compound is going to be KF. And the reason why we don't have little ones here, because normally our middle step would be that we'd have K1F1. But if you remember earlier, I told you we're not really in chemistry, we don't write ones. So because they don't write the ones, if you've written the K, obviously there's 1 of those there. And if you've written the F, there's 1 of those there. So because they're there, you don't need to write the ones. So this is our new compound, and the formula is completed. And here's the thing. So this is called potassium fluoride. Remember the IDE ending. And then the ones, here it says cancel out, which they do cancel each other out, and so they become invisible. But mostly it doesn't even have to cancel out. Anytime there's a 1, we don't write it. So you can do the same thing again when you have calcium and chlorine. So this is calcium and this is chlorine, and this is your second example. So in case you start by just writing one atom of each, you can't always do that. If you need more, all you have to do is just add another one. So calcium here has 2 valence electrons and chlorine has 7. So this chlorine will take 1, but it can only take 1 because it can't become more than full. That's super important. You can't become more than full. So then this other one over here has another one to give. So it's going to give it to this calcium down here. And when it gives to this calcium, it's made this one full and it's made this one full. So it took 1 calcium for 2 chlorines. So when you do the cross down here, when you look at the periodic table, calcium is in the second group, so it has 2 valence electrons, which we've already talked about. That gives it a charge of 2+. Chlorine, group 17, 1 valence electron, will get a charge of 1-. When we cross these 2 down, you're not going to have the numbers with the positive and negative come down. You're just going to get Ca1, Cl2. And then you're going to put them together and write CaCl2. Because this 1 over here is invisible, and we don't need to write it down, but it took 2 chlorines to satisfy 1 calcium. So you don't have an equal number, so they don't cancel each other out. Does that make sense? We're going to do a bunch more of these to make sure that this makes sense. So let's move this over here. I'm sure I missed a couple of blanks on there. Again, I will always post those for you with the full answers, but I want to make sure you can do this because this is the most important. So here we've got sodium. Sodium has 1 valence electron. It's in group 1, so it really wants to get rid of that one. Chlorine, group 17, 7 valence electrons. It really wants to take 1. So my sodium is going to throw its electron over here, which means that I'm going to be left with Na, and I'm going to have a 1+ because it's in group 1, but also because it's given away 1 electron, so it's got an extra proton. Then I'm going to have chlorine, Cl, and I'm going to have 1- because it took in 1 electron, and it's in group 17, so it has a 1- charge. Then we're going to draw these down. Now because I can't go down, I'm going across. So then I'm going to get Na1, Cl1. In grade 9, I will accept this as an answer. In grade 10, you will get this wrong. The reason why I'll accept it in grade 9 is because you're learning what all of these parts are, and we're learning at a distance, and it's hard. So I will accept this, but next year they will not. So you need to start practicing for next year. So I will always remind you. At the end of this, you're going to write a little solid because all ionic bonds are solid at room temperature. Then you're going to come over here a little bit more, and you're going to write NaCl because you're going to get rid of both of those ones because they shouldn't be there. And then you're going to write solid. Then underneath that, you're going to write the chemical name. So the chemical name is sodium chloride. Remember, these end in IDE. Sodium chloride. You do not have to capitalize chemical names. They don't need to be capitalized. Okay, so I'm hoping that this one made sense. I'm going to do these other ones, and I'm watching the time because I can only, this thing will run out at 15. So here I've got magnesium. Magnesium's in group 2. It has 2 to give away. Oxygen has 6. It has 2 that it wants to take. So it's going to take 2 from the magnesium. Does that make sense? They don't need any extra ones. We don't need to add any more in there because it's going to take those 2 and it's going to be perfectly happy. So when it does that, you're going to end up with oops, that's an N. Mg2 plus O2 minus. Now you're going to cross these down again. But at this point, you should realize that they are going to cancel each other out. Does that make sense? So a charge of 2 plus, a charge of 2 minus is a neutral atom. It's not going to need any extras. So you're going to get, you might write Mg2O2. Again, in grade 9, I will accept this. But really, it should be written as MgO because you only needed 1 magnesium for every 1 oxygen atom. So if you can divide these down lower, you got to go to the lowest common multiple of those. Or lowest common denominator? Can't remember which one it's called. And again, you're going to write solid magnesium oxide is going to be your title. Okay, so now we're going to come back over here. Now instead of magnesium with oxygen, we have sodium. So sodium's going to give 1 to oxygen, and oxygen's going to be like, that's not enough. I need more. I am not satisfied. I am not stable. So another sodium atom will have to come over and donate its other electron. So now we're going to have sodium 1 plus, oxygen 2 minus. Then you're going to cross this down and you're going to get Na2O1. You can't cancel these down any further. So you're going to get Na2O. You don't have to write the 1. So then you're going to add solid, because everything's solid at room temperature. That doesn't mean you can't dissolve it in water. It just means it's solid at room temperature. And this is going to be called sodium oxide. As you can see, all of these are ending in IDE. I'm hoping that you're with me so far. We have one left before, well, hopefully before the end of this video. So I have aluminum. Aluminum wants to get 3, and I have bromine. This is a really weird way of writing an R, but it's bromine. And it can only take 1. So I've got aluminum, and it's going to give to this bromine. And then I'm going to take another bromine. Can you see those dots? Good. And I'm going to take and give this one up here. And I've got to get another one. Bromine. Don't just write B. That's a different element. Be careful. I'm saying that to myself, not to you. So I needed 3 bromines because aluminum, if I look on my periodic table, has a 3 plus charge. Bromium has a 1 minus charge. So I'm going to bring these down, and I'm going to get Al1 Br3, which we don't have to write the 1. So then I'm going to write AlBr3 solid, and I'm going to write my chemical formula of aluminum bromide, ending in IDE. So I realize that this is a lot of information and it's kind of hard. At the bottom corner here, it says, how are you feeling about the basics of ionic bonding? If you are feeling like you don't get it, you need to book a one-on-one session with me, because you can do this. It looks hard, but you can. If you're in the, I think I got it, practice, and if you realize in the practice one, you're not getting 100%, come and book time with me. And if you're like, I got this, and then you go and do the practice one, you get 100%, perfect. Then you do have it. Excellent. But come and get help early in this unit. All right. I'm going to sign